Hi students, in the last video we were study about the application of Kirchhoff's laws. That is first application Wheatstone's meter bridge. Wheatstone's meter bridge is used for the measurement of unknown resistance, and Kelvin's method it is used for the measurement of resistance of galvanometer. In this video we will study about applications of Wheatstone's bridge for the measurement of strain. So our point is Wheatstone's bridge for strain measurement. That is, for the measurement of strain, we use Wheatstone's bridge. How we use Wheatstone's bridge for the measurement of strain, that is studied in this point. Strain gauges are commonly used for measuring the strain. That is, for the measurement of strain, generally strain gauges are used. Their electrical resistance is proportional to the strain in the device. In practice, the range of strain gauge resistance is from 30 ohms to 3000 ohms. Means, using strain gauge, we measure the resistance in the range of 30 ohms to 3000 ohms. For a given strain, the resistance change may be only a fraction of full range. Therefore, to measure small resistance change with high accuracy, we use the Wheatstone's bridge. For the measurement of strain of a strain gauge device, Wheatstone bridge configuration is used, and the circuit diagram which is used for the measurement of strain of a strain gauge with the help of Wheatstone bridge is given below. This figure shows that there are two resistors R1 and R2 which having equal values, and a third resistor R3 which is having variable value. Means in this third resistor we connect the resistance box which gives the variable value of resistance with no force applied to the strain gauge. Rheostat is varied. Means in this Wheatstone network there are four resistors, that is resistor R1, resistor R2, resistor variable resistor R3, and in the fourth resistor, in place of fourth resistor, we connect the strain gauge with no force applied, and rheostat is varied. Finally, position such that voltmeter will indicate zero deflection. At the place of fourth resistance, we connect the strain gauge in such a way that voltmeter will indicate zero deflection, that is, bridge is balanced. The strain at this condition represents the zero of the gauge. If voltmeter shows zero deflection, then strain at this condition where circuit is balanced, then strain at this condition represents the zero of the gauge. Means resistance of the strain gauge is zero. If the strain gauge is either stretch or compress, then the resistance will change, and this causes changes in the bridge condition. Means bridge is unbalanced. This produces a voltage indication on voltmeter which correspond to the strain change. If we compress or stretch the strain gauge, then there is change in the resistance value which causes bridge is unbalanced, and due to this there is change in the voltmeter reading, which gives us change in strain value. If the strain applied on the strain gauge is more, means if we stretch or compress the strain gauge more, then the voltage difference across the meter terminals is more, means voltmeter shows more voltage difference. If the strain is 0, then the bridge balance and meter shows 0 reading, means strain having strain gauge is 0, then bridge is balanced and voltmeter shows 0 reading. This is the application of precise resistance measurement using a meter bridge, means with the help of Wheatstone's meter bridge we can measure the resistance having very low value with high accuracy. This is one of the application of Wheatstone's meter bridge. After that, the third application of Kirchhoff's law, that is potentiometer. Potentiometer, that is a device which is used to measure the potential difference as well as EMF of the cell. It is a device which is used for the measurement of potential difference, so known as potentiometer, as well as EMF in the cell. We know that voltmeter is a device which is used for the measurement of potential difference between 2 points in a circuit. If we measure potential difference between 2 points in any circuit, then we generally use voltmeter. And an ideal voltmeter which does not change the potential difference to be measured should have infinite resistance so that it does not draw any current. But in practice, it is not possible. Practically, a voltmeter cannot be designed to have an infinite resistance, so that potentiometer is used in place of voltmeter. Potentiometer is one such that, or potentiometer is a device which does not draw any current from the circuit. It is an ideal voltmeter. It is used for the measurement of potential difference. So potentiometer is a device which is used in place of voltmeter, because voltmeter is a device which is used for the measurement of potential difference between 2 points in a circuit with infinite resistance. But in actual practice this is not possible. Due to this, potentiometer is used in place of voltmeter. Potentiometer is a device which does not draw any current from the circuit. It acts as an ideal voltmeter. So this potentiometer instrument works on the principle which is given below, that is the principle of potentiometer. The potentiometer instrument works on the principle that the potential difference applied across a wire is directly proportional to length of that portion. That is the principle of potentiometer. Potential difference applied across a wire is directly proportional to length of that wire. That is the principle of potentiometer. So for studying the principle of potentiometer, we first see potentiometer consists of a long wire, that is wire AB, of length capital L and resistance capital R, having uniform cross-sectional area A. Means if we consider a potentiometer wire AB which is having length capital L, resistance capital R and a uniform cross-sectional area A, as shown in the figure 9.6. This figure gives us construction of potentiometer wire, gives us construction of potentiometer instrument. In this, wire AB is the potentiometer wire having length capital L, resistance capital R, and this wire having uniform cross-sectional area A. That is the construction of potentiometer instrument. Along that wire AB, a source of EMF E and an internal resistance small r is connected. The cell which is having small internal resistance R is connected across wire AB. That is the construction of potentiometer instrument, in which a long wire of length capital L with resistance capital R and uniform cross-sectional area capital A, along with a cell having source of EMF small e or E with internal resistance small r, as shown in this figure 9.6. That is the construction of potentiometer instrument. Cell of EMF E having internal resistance R is connected across AB, as shown in the figure. When the circuit is switched on, then current I passes through the wire. When circuit is switched on, then a steady current capital I passes through the wire. Then current across wire AB is given using Ohm's law. I is equal to E upon capital R plus small r, where E is the EMF of the cell and capital R plus small r is the total resistance of the circuit, and I is the steady current flowing through that circuit. Then current through wire AB or current across wire AB is given by I is equal to E upon R plus R. Then potential difference across wire AB is given by VAB is equal to I into R, where I is the current flowing through wire AB and R is the resistance across wire AB. Therefore, VAB is equal to ER divided by R plus R. VAB is equal to ER upon R plus R, where we put the value of I is equal to E upon R plus R. Therefore, VAB means potential difference across wire AB is equal to ER divided by R plus R. Therefore, potential difference per unit length of wire is given by, that is, VAB upon capital L is equal to ER upon L into R plus R. Means if we divide the potential difference by length of that wire, potential difference across wire is divided by length of that wire, then we get VAB is equal to ER upon L into capital R plus small r. As long as E remains constant, then VAB upon L remains constant. Means the EMF supplied by the cell remains constant, then potential difference per unit length of the wire remains constant. Therefore, that fraction potential difference per unit length of the wire, that is VAB upon L, is known as potential gradient along wire AB and is denoted by K. Potential difference per unit length is known as potential gradient and it is denoted by K. So we define potential gradient. How we define potential gradient? So we define potential gradient as potential difference per unit length of the wire. That is the definition of potential gradient denoted as symbol capital K. That is potential difference per unit length of the wire. After that, in this circuit or figure 9.6, consider a point C. That is the point C, which is on the wire or along wire AB at a distance small l from point A. That is the point C which is present along wire AB with a small distance small l from point A as shown in the figure. Then potential difference between A and C is given by phi AC. The potential difference along wire AB is given by phi AB. AB suffix for potential difference between A and B, and AC suffix for potential difference between A and C. Therefore, phi AC is equal to K into small l. That is, phi AC is directly proportional to L because K is the constant. Then phi AC upon L is equal to constant, and if phi AC upon L is equal to constant, then phi AC is directly proportional to small l. That is, potential difference across wire AC is directly proportional to length of wire AC. Thus, the potential difference between 2 points on the wire is directly proportional to the length of the wire between them, provided the wire of uniform cross-sectional area. The current through the wire is same and temperature of the wire remains constant. That is the principle of potentiometer. What is the principle of potentiometer? So principle of potentiometer is potential difference between 2 points on the wire is directly proportional to length of the wire between them when and only when current through the wire is same and temperature of the wire remains constant. That is the principle of potentiometer. When current through the wire is same and temperature remains constant, this is the condition. And that condition, the potential difference between 2 points on the wire is directly proportional to the length of the wire between them. Using that principle, this potentiometer instrument is work. So, students, in this video, we see one of the application of Kirchhoff's law, that is potentiometer instrument, and the principle of potentiometer. In the next video, we will see uses of potentiometer. Thanks.